Welcome to this web seminar, a quick introduction to Mplab Sim. My name is Daryl Johansson, and I'm a manager in the Development Tools group at Microchip. The centerpiece of our toolset is the software Mplab Integrated Development Environment, or IDE. Mplab IDE has enjoyed many years of use and evolution, tracking Microchip's expanding catalog of microcontrollers and digital signal controllers. One of the most popular elements of Mplab is the software simulator, Mplab Sim. This component, like the Mplab IDE, is free. The simulator runs on your PC to simulate the actions of the various PIC and DS-PIC microcontrollers. You can verify your software routines execute as designed, and debug, test, and inspect your code. Mplab Sim helps you optimize your application with timing tools, trace tools, and various graphical analyzers. We'll cover the basic elements of the simulator in this web seminar, including how to configure Mplab to use Mplab Sim as the current debugger, how to run your code in Mplab Sim, halting at a breakpoint, how to single-step through your code, how to set watch points on data variables in your code, how to run and halt your code, how to use a stimulus to simulate external inputs to your hardware, how to use the debug variable to make conditional code execution while debugging, how to insert fprintf statements in your code to monitor the executing routines, how to measure the execution time of your code, how to record code as it executes, capturing its history in a buffer to be reviewed. You should already be familiar with Mplab IDE before going through this seminar. You might want to watch the Introduction to Mplab seminar first. The Mplab IDE desktop has all the standard Windows features, menus, toolbars with icons, and a status bar at the bottom. To select the simulator, select the Debugger pull-down menu and scroll to Select Tool. A submenu pops up. Scroll down to select Mplab Sim. Now the status bar shows Mplab Sim as the current debugging tool. Mplab deals with applications as projects. Projects are the source files that are used to build the application, along with compilers, assemblers, and linkers. In this project are three files, main.c, delay.c, and an assembly file, int_devices.s. All will be compiled using the Mplab C compiler and its tool suite for the DS-PIC family of digital signal controllers. But this process is the same for the other families of Microchip microprocessors. For more information on setting up a project, see the Introduction to Mplab seminar referenced earlier. When all the source code is correctly written and the project configured properly, click the Build icon on the toolbar to compile the files. If the project builds with no errors, the output window will show Build Succeeded. Open a source file for editing or debugging by double-clicking on the file name in the project window. After a project successfully builds, position the cursor on the desired line, and click the right mouse button to bring up a menu to set a breakpoint. In the source file, the breakpoint is shown by the red symbol with the letter B. Pressing the Run icon starts the simulation, stopping at the breakpoint. The green arrow on top of the red B shows the current program counter location at the breakpoint set in the function main. Pressing the step icon, single steps one line in the code. Watch windows inspect variables in your code. Select the Watch window from the View menu. Use the right pull-down to see symbols. Select the variables to watch. Then press the Add Symbol button to enter them in the Watch window list. Now when the program is halted or stepped, the variables will show changed values in red. Pressing the Run icon lets the processor continue running the code from the current breakpoint. The status bar at the bottom disappears and is replaced by a running progress bar. Selecting the Halt icon stops program execution at the current program counter location, just as if it encountered a breakpoint at that instruction in the code. In this code, after pressing single step, the green arrow does not advance. The code is in a while loop, waiting for a switch on port pin RD7 to go high. The action of the switch on pin RD7 can be simulated with a stimulus function. Mplab Sim can respond to the action of external hardware, such as switches, with the stimulus functions. The stimulus dialog is accessed from the debugger pull-down. Scroll to Stimulus and create a new workbook. The stimulus workbook has tabs for the various types of stimulus. There are 6 tabs, offering options to apply stimulus to the simulator. Regular, repeating waveforms, lists of voltage levels, events from files, and sequences of data values can be injected into registers and applied to external pins. The asynchronous stimulus tab can be used to simulate the action of pressing a switch. Click on the Pin SFR column to select the pin RD7. In the Action column, set the action for the pin to pulse high when pressed. In the Width column, a somewhat arbitrary value of 5 makes the pulse last 5 cycles, just ensuring the pulse lasts beyond a single instruction. Press the Fire button to apply the pulse to the RD7 pin. The output window logs the action. Press the single step key to go forward now, into the delay routine. The next step enters the delay routine. Delay routines such as this are often used to slow things down, so that a display can be seen by the human eye, for instance. When simulating, which runs at a slower speed than the actual processor, these delays are often not needed. While using the simulator, we just need to know that the delay routine is called, but we don't want to step through thousands of iterations of a delay loop. Use the variable __debug to change the way the delay loop operates while debugging using the simulator. To modify the delay routine to operate differently while debugging, but retain its function in the application, add a #ifdef function to check the state of the variable __debug. If the variable __debug exists, then we'll skip the thousands of loops in the delay routine and just exit. Additionally, an fprintf function can print out a message to remind us that the delay routine operates differently while debugging with the simulator. In order to use the printf routine to echo that the delay routine executed, but in a different way when debugging, the stdio.h file must be included. A couple of other things need to be set up to use fprintf. Under the Project menu are the build options. The Mplab Link 30 tab needs to generate a heap to handle the character storage for fprintf. 256 bytes is ample for any message we need to print out. Messages from an embedded controller must come from a peripheral device on that controller. The UART needs to be configured to send I/O to the output window. The simulator settings dialog is on the debugger menu. Check the box to enable the UART I/O. And check this button to see its messages in the output window. Now, as you go through your code, you'll see the fprintf string in the output window each time the delay function is called. Mplab Sim has tools to analyze how the code is running. The stopwatch can time the execution of code. While stopped at a breakpoint, select the stopwatch from the debugger menu, then press the 0 button to clear its contents to get ready for a measurement. Run to the next breakpoint, and the stopwatch accurately measures the instruction time in cycles and microseconds. Another way to optimize code is to use the trace analyzer. While setting breakpoints and single-stepping through code is one way to see how your code is functioning, an alternative is to use the trace facilities of Mplab Sim to record instructions as they execute while the simulator is running. Use the debugger menu to select the settings dialog and enable the Trace All checkbox. Press Run, then halt or stop at a breakpoint, and view the trace window from the View menu. The upper half of the trace window shows the instruction flow. When you click on an instruction there, the corresponding section from the source code is shown in the lower half. Trace is useful to see how you got to a certain point in your code. That's a quick tour of the simulator. We hope this will give you a few pointers and you'll explore these and other simulator features. If you haven't already done it, now is the time to get started with Mplab IDE. Go to our website at www.microchip.com/mplab and download your free copy of Mplab software. This is the end of our presentation. Thank you for your time.